Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. Today's concept is binomial theorem. I will be explaining how to expand a binomial using this theorem. You will also learn how to find any term in this expansion. Before getting into the details, you need to have learned the concept of permutation and combinations in order to understand this theorem. Also, you need to have a notebook and a pen with you, as I will be often asking you to pause the video and do some calculations on your notebook. So, let's start. How do we expand binomials? A plus b to the power of 1 can be expanded as a to the power of 1 plus b to the power of 1. This is simple. Now you need to take your notebook and pen and expand a plus b to the power of 2, which is a plus b the whole square. Expand this binomial. Pause the video here, finish expanding and check your answer. Now I'm going to give you the answer here. A square plus 2ab plus b square. If you have written this in any other order, please rearrange this and write it in the same order as seen on the screen. A square, first term, second term should be 2ab, and the third term should be b square. So it should be a square plus 2ab plus b square. Please write this in this order. I'll tell you why this is important. Next, expand a plus b to the power of 3. Again, pause the video here, expand and then continue with the video. The expansion is a to the power of 3 plus 3a square b plus 3ab square plus b to the power of 3. Again, if you have arranged it in different order, please rearrange this and write it in the same order as seen on the screen here. A cube as the first term, 3a square b as the second term, 3ab square as the third term, plus b cube as the fourth term. Now try to expand a plus b to the power of 4. Again, pause the video here. Are you ready? This is the expansion, and I hope you have written this in the same order as seen on the screen. A power 4 plus 4a cube b plus 6a square b square plus 4ab cubed plus b to the power of 4. Now let's see if there are any patterns that can be seen here. A plus b to the power of 5. Instead of actually expanding, let's see if we can identify some patterns and find the terms in the expansion of a plus b to the power of 5. You would have noticed that the first terms in all the expansions have a to the power of the same number of power as the power of the binomial, correct? So a power 3 for a plus b power 3, a square for a plus b the whole square, a power 4 for a plus b to the power of 4. Therefore, we should have a power 5 as the first term here. And the next term has some numbers. Here you have 2, here you have 3, here you have 4. But what happens to the power of a? It gets reduced by 1 unit from this power. So it was a power 4, now it is a cube. A square, it is a power 1. A power 3 became a square, a power 4 became a cube. Therefore, a power 5 should give you a power 4. And what about b? In the second term, you can see that you have b to the power of 1 in all the expansion. Therefore, the next term should be a number with a power 4 into b. The next term should be a power 3. 1 less than a power 4 should be a power 3. And 1 more than b should be b power 2. So, some number a power 3 and b power 2. Next should be 1 less in a power and 1 more in b to the power. So, plus a number a square b to the power of 3. Again, 1 number less for power of a and 1 number more for power of b. Therefore, plus a number a b to the power of 4. And the last term will have only b to the power of the number that is the same as the power of the binomial. Therefore, we will have b to the power of 5 here. As we had a power 5 in the beginning, the end will always be having b to the power of 5. Now the job is to find the numbers in these places. I would like you to actually expand a plus b power 5 and see what the numbers will be in these places. Pause the video here, find the expansion and come back to check your answer. Are you ready? So the first term is a power 5. The second term will be 5a power 4b, third will be 10a cube b square, and then fourth will be again you have the same coefficient 10, but the term is a square b cube, and then 5a b power 4 plus b power 5. Now we need to go on with another expansion for a plus b to the power of 6. Let's see if we can follow the pattern. First term is a power 6 and the last term is b power 6 according to the pattern that we had before. And you can also notice that you have 2 for a plus b power 2. You have a 3 here for a plus b power 3. 4 for a plus b power 4. 5 for a plus b power 5. So if you are writing in the same order as we have written in all these rows, that is why I asked you to write it in this particular order. If you have written in the order that you reduce the power of a and increase the power of b, then the second term will have the same number as the power of this. Therefore, I should have 6 a to the power of 5 and b. We do not know what should be the next term, but we can see that the last but one term has the same coefficient as the second term. So here it is 5 because it was 5 here. Here it is 4. 1 before b power 4 I had 4 because the power is 4. Therefore, I should have the same 6 here, and I should have a b to the power of one number less than this number, right? So a b to the power of 5 will be the last but one term. So we can identify these 4 terms from the pattern above, but it's very difficult to identify the in-between terms. But what we know is the a power decreases and b power increases, but we need to find the numbers there, right? In order to find the pattern with the coefficients, let's consider the coefficients of these places as 1, and then let's consider all the numbers without the terms. So these are the coefficients for the expansions for each of them. So the first a plus b power 1 will have coefficients 1 and 1. The coefficients for a plus b power 2 will be 1, 2 and 1, and etc. Now what you can notice here is these two added together will give you 2. These two added together will give you 3. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. So you get a pattern from the previous row. So you can find the coefficients from its previous row. For example, 1 plus 4 gives you 5. 4 plus 6 and 6 plus 4 will give you 10, and the last but one term will be 4 plus 1, which is 5. So continuing like this, we get for a plus b power 6, 1 plus 5 will give you 6. So the next number should be 5 plus 10, which should give you 15. And again I repeat, it is only when you write it in the decreasing power of a and increasing power of b. So you have to maintain the order of the terms. So if you maintain that order of the term, then you can actually add the previous two numbers to get the coefficient of the present line. Next, 10 plus 10 gives you 20, 10 plus 5 gives you 15, and 5 plus 1 gives you 6, and so on. The first and the last term will always have the coefficient of 1. Therefore, a power 6 and b power 6 in the extremes. We have 6, 15, 20, 15, and 6 in the middle terms. Now I am going to ask you to expand using this a plus b power 6 row. Try to find a plus b power 7. Pause the video here. Use this pattern and find all the coefficients. Write it in the way that we have written so far. I am going to give you the answer now. A plus b power 7 will be a power 7 plus 7 a power 6b, and the coefficient next is 21, next is 35, 35, 21, 7, and b power 7 as the last term. Check your answers now if you have written this in the same order. A power 7, 7 a power 6b, 21 a power 5, b square, and so on all the way up to b power 7. So you can now find a plus b power 8, a plus b power 9, etc. But if you want to find a plus b to the power of 15, for example, you need all the rows from 1 all the way to a plus b power 14. Yes, it's going to be really tough, and more than that you will not have space in your paper. So this method is not going to help us to find a plus b to the power of any bigger numbers. So we need to identify some other pattern. So for that we need this Pascal's triangle. Let's write the coefficients as before for each of these expansions. A plus b to the power of 2 will have 1, 2, 1. Power 3 will have 1, 3, 3, 1, and so on. I am writing this in a pattern as a triangle. This arrangement of these numbers is called Pascal's triangle. Now in order to go for the next pattern, we need to know permutation and combinations, and also you need to know NC0 is equal to 1 and NCn is equal to 1 for any n. So the ones on this either side of the triangle can be written as 2C0 and 2C2 for the first line, and for the second line I can write this as 3C0 and 3C3, NC0 and NCn, remember. So for power of 3 I will use 3C0 and 3C3 for the extreme ones, and for power 4 I will use 4C0 and 4C4, and so on for 5 and 6. So I have given the combinations at the extremes of the Pascal's triangle. What about the in-between numbers? For example, in power 2, 2 can be written as 2c1. Therefore, the coefficients of a plus b to the power of 2 will be 2c0, 2c1 and 2c2. Whereas for a plus b whole power 3, it will be 3c0, 3c1, 3c2 and 3c3 because 3c1 and 3c2 are equal to 3. Whereas for a plus b to the power of 4, 4c1 is 4, 4c2 is 6, 4c3 is again 4. Therefore, the coefficients will be 4c0, 4c1, 4c2, 4c3, 4c4 in that order. So you can fill in for a plus b power 5 and a plus b power 6. Pause the video here and fill in the places for a plus b power 5 and power 6. Are you ready? 5c0, 5c1, 5c2, 5c3 and 5c4. Next is with 6. 6c1, 6c2, 6c3, 6c4 and 6c5, and the extremes are 6c0 and 6c6. Now can you write a plus b to the power of 15? The coefficients will be starting with 15c0, 15c1, 15c2 all the way to 15c15. You can see that you don't need the row for a plus b power 14. You can directly write the coefficients for a plus b power 15 now, and you know how to write the terms as increasing power of b and decreasing power of a. Therefore, combining all of them together, pause the video here and expand a plus b to the power of 15 in terms of 15c0, 15c1, etc. Here is the answer. A plus b power 15 will be 15c0 a power 15, 15c1 a power 14b, and so on. A's get reduced by its power and b gets increased by its power. All the way up to the last term will be 15c15, a to the power of 0, b to the power of 15. You can see that 15c0 is 1, therefore this term is actually a power 15. 15c15 and a power 0 both are 1, therefore this is actually b to the power of 15. So we have the extreme terms as a power 15 and b power 15. In between terms will be having the coefficients of 15c1, 15c2, etc. I repeat again with the decreasing power of a and increasing power of b. So let's generalize the theorem. If I have a plus b to the power of n, it can be written as nc0, a to the power of n, b to the power of 0 to start with as a first term. The next term will have the coefficient nc1. nc0, nc1, nc2, nc3, ncn are the coefficients, and a starts with a power n minus 1, a power n minus 2, a power n minus 3 and a power 0 ends at a power 0, and b starts with b power 0, b power 1, b power 2, b power 3 all the way up to b power n. You can see that nc0 and b power 0 are 1, therefore the whole term is just a power n, and in the same way this term is also b power n because ncn and a power 0 they are both equal to 1. And in between terms will have both a and b with coefficients as a combinations of n. This is called binomial theorem. You would have noticed that the number of terms in the expansion is always n plus 1 if we are raising a plus b to the power of n. Because we start from nc0 to ncn, therefore the total number of terms will be n plus 1. Let's find any general term in the expansion. So let's consider the same expansion a plus b power 15. What do you mean by general term? This term is called term 1, 15c0 a power 15, which also has b power 0. The next term 15c1 a power 14b is called term 2. 15c2 a power 13 b square is called term 3, and this is term 4, term 5 and so on. And if you keep writing these terms as it is, this will be T13, term 13, term 14, term 15, and you know that there are 16 terms in a plus b power 15 expansion. This is the 16th and last term, which is just b power 15. Now let's write first 4 terms separately. So T1 is 15c0 a power 15 b power 0. So the zeros match here. In the same way, T2 will be 15c1 a power 14 b power 1. Pause the video here and complete for T3 and T4. So T3 is 15c2 a power 13 b power 2, and the 2 here are the same. 15c3 a power 12 b power 3 will be T4. So what is the pattern here? Therefore the power of b and the combination with 15 are going to be the same numbers, and which is also equal to one number less than the term. So fourth term has power 3, third term has power 2, second term has power 1, and first term has power 0, which means the term number minus 1 will give you these two numbers in the terms. Whereas if you look at the power of A, this is 15 minus the power of B. Now you know what to do if you are asked to find T7, for example. So the number would be 15C, one number less than 7, A to the power of 15 minus one number less than 7, and B to the power of one number less than 7. Therefore, the answer for this is 15C6, A power 9, B power 6 will be term 7 in the expansion of A plus B to the power of 15. Now find T12. Pause the video here, find T12 and look for the answer. Here is the answer for T12. So simplifying, 15C11, A power 4, B power 11. Now find T10, 15C9, A to the power of 15 minus 9, which is 6, B to the power of 9. And T8 will be 15C7, B power 7, but 8 will be to the power of 15 minus 7, which is 8. And you can notice that these two numbers added together will always be equal to 15. Let's see the expansion of A plus B to the power of 10. Find the fifth term in this expansion using the previous concept. So you will have 10C, one number less than 5, A to the power of 10 minus 4, and B to the power of one number less than 5, which will be 10C4, A to the power of 6, B to the power of 4. This will be the fifth term in the expansion of A plus B to the power of 10. Now what term is 10C8, A to the power of 2, B to the power of 8? Which term this will be? For that you need to look for these two numbers, which is going to be 8, which means it is 1 less than the number of term. Therefore this is term number 9, which is also written as T9. So T9 in this case is 10C8, A square, B to the power of 8 in the expansion of A plus B to the power of 10. So consider A plus B to the power of n in general. So the first term in this case will be nc0, A power n minus 0, which is n, B power 0. You can see that this can also be written as T0 plus 1. Using these two numbers here to match with the numbers there, we can say that T1 is nc0, A power n, B power 0, which can also be written as term number 0 plus 1. So for example, term number 9 will have nc8, A power n minus 8, B to the power of 8, which can be written as T8 plus 1 using these two numbers. Therefore, in general, TR plus 1 will have NCR, A power n minus R, B power R. So if you have NCR and B power R, then it is TR plus 1. So this is the general term in the expansion of A plus B to the power of n. This is explained more in detail in the website ganatika.com. In order to access this topic, go to the Contents tab. Click on the Contents tab. You will be taken to a page called Topics. And if you go down, you can see all the chapters. Click on the binomial theorem topic and then click on this Go to Binomial Theorem page. If you are registered in this website, you will be able to see this page. And these are all the detailed explanation given in this page on binomial theorem. You can also see that Pascal's triangle is also explained very well in this website. So register in this website for free and enjoy the full essence of mathematics. I hope you enjoyed this video. Thanks for watching. Bye bye until next time.